topic of this video is properties of real numbers and algebraic expressions. The following table lists the defining properties of the real numbers. These laws define how the things we call numbers should behave. The first law for addition is the commutative property. The commutative property states for all real numbers a, b, a added to b is equal to b added to a. So you can see all that's been done is a change in the order that the terms are written in. The same is true for multiplication and the commutative property. For all real numbers a and b, a multiplied by b gives us exactly the same product as b multiplied by a. So no matter if it's addition or multiplication, the commutative property deals with a change in the order of the terms. The associative property of addition states for all real numbers a, b, and c, a added to the quantity of b plus c is exactly the same as the quantity of a plus b added to c. So notice that a is written first on each side of the equation, and then b, and last c. So the order is not changed, the grouping has been changed. First we had b and c grouped, and then we're grouping a and b. So you will notice with addition, the associative property has a change in the grouping of the terms. For multiplication, the associative property shows that the product of the group AB multiplied by C is the same as A multiplied by the grouping or product of B times C. So again, we've just changed the grouping. The associative property deals with a change in grouping. So one way I like to explain how to tell the difference between these, think about your commute to work or your commute to school. Whether you're walking or you're driving or riding a bicycle, you are changing the order that you appear on the road or the sidewalk. You can pass other people, you can remain behind them, you can be next to them. You're somehow able to change the order that you appear in. The associative property is a change in grouping. So think of your associates, maybe at work, or your classmates. You sometimes work in groups, and you can change the members of the group. So the associative property deals with a change in grouping. Next, we have the identity property. For addition, the identity property states that if you have a real number a, you can add 0, and that does not change the value of that real number. You still have a. For multiplication, multiplication of 1 is the multiplicative identity, because any real number multiplied by 1 would retain the value of that real number. You still would have a. Additive inverse refers to opposites. A added to the opposite of a will add to 0. So a number added to its opposite will make 0. That is the additive inverse. The multiplicative inverse is for every real number a except for 0. Remember, we can't have division of 0. There exists a real number 1 divided by a. So any real number multiplied by its reciprocal will equal 1. Finally, we have the distributive law, or the distributive property. For any real numbers a, b, c, a multiplied by the quantity of b plus c is equal to the sum of these products, a times b added to a times c. And we'll talk more about the distributive law in another video of this course. So what's important to know In the table we just talked about, we only included addition and multiplication. So what about subtraction and division? The commutative and associative laws do not hold true for subtraction or division. A minus B is not equal to B minus A. So if we change the order, we're not going to have a true statement. The same with A divided by B. That is not equal to B divided by A. And with our grouping, A minus the quantity B minus C is not equal to A minus B minus C. A divided by the quantity B divided by C is not equal to this quantity A divided by B divided by C. We'll try some examples with numbers, and then you'll see why the associative and commutative properties don't hold true for subtraction and division. Let's start with A minus B. So if I have A minus 5, does that equal 5 minus 8? 8 minus 5 equals 3. Does that equal 5 minus 8? $5 minus $8, that's negative 3. Those are not the same numbers, so this is not true. A divided by B is not equal to B divided by A. An example here might be something like 8 divided by 4. Does that equal 4 divided by 8? Well, 8 divided by 4 makes 2. 4 divided by 8 would be 1/2. So those are not equal. Again, you can see how division and the commutative property do not work. So subtraction and commutative property doesn't work. Division and the commutative property doesn't work. Let's try the associative property where we're changing the grouping. All right, so for this first one, well, let's try 9 minus the quantity of 3 minus 1. And I'm just making up some numbers here just to give an example. So A is 9, B is 3, C is worth 1. So I have to make sure I use those values for A, B, C on the other side. Now I'm grouping A minus B. So that would be 9 minus 3, then subtract 1. So on the left side, I would have 9 minus 2. On the right-hand side, I would have 6 minus 1. So when I simplify, 9 minus 2 would make 7. 6 minus 1 makes 5. 7 does not equal 5. So the associative property of subtraction does not hold true. It does not work. Now let's try the last one, division and the associative property. Let's see how that turns out. 12 divided by the quantity of 6 divided by 2, and see if that is equal to the quantity of 12 divided by 6 divided by 2. So we're just changing the grouping, not the order. Here we'd have 12 divided by 3. Does that equal 2 divided by 2? So 12 divided by 3 would make 4. Does that equal 2 divided by 2, which is 1? No, 4 doesn't equal 1. So just coming up with some values for A, B, C, you can substitute them to see if these properties work or not for subtraction and division, and we just proved that they don't work. So what these laws mean is that order and grouping do not matter for addition and multiplication, but they certainly do matter for subtraction and division. This will become important when we start talking about algebraic expressions and simplifying algebraic expressions. Often what we will want to do with an algebraic expression is rearrange it somehow to simplify it, and that will be explained in future videos. If the operations are all addition and multiplication, we don't have to worry about it too much. But once we start including subtraction and division, we'll have to pay careful attention. Fortunately, we can always think of subtraction as adding the opposite And we can think of division as multiplying by the reciprocal. That might be helpful. So you may have noticed already that the commutative and associative laws read exactly the same way for addition and multiplication. There was no difference between them other than the notation. So the commutative property of addition and multiplication deal with the order of terms, and the associative properties for addition and multiplication deal with a change in the grouping of the terms. The distributive law is extremely important, and it's impossible to understand algebra without being thoroughly familiar with this law. Here is an example of how to use the distributive law or distributive property. We have 2 multiplied by the quantity of 3 plus 4. So according to the order of operations rules, we would begin inside of this quantity with 3 plus 4. So if we do that, that means 3 plus 4 makes 7. So we are multiplying 2 times 7, which gives us 14. But we could also look at the same problem with the distributive law. So of course we should still get the same answer. If we don't, something went wrong. The distributive law tells us that 2 would be distributed to 3, and then 2 is distributed with 4. So 2 times 3 added to 2 times 4. When we simplify, 2 times 3 would give us 6, and 2 times 4 gives us 8. 6 plus 8 gives us 14, which indeed matches 14, which we got from working with the same problem using the order of operations. So does it matter which way we work it? No. Now let's use our knowledge of the distributive property, the associative property, and the commutative property of addition and multiplication to simplify and justify our steps. We're going to simplify 3a minus 5b plus 7a. So in the first step, we've simply just written the problem. It's the original problem that was given. Then we write 3a plus 7a minus 5b. What has changed? Notice 3a is still the first term, but now negative 5b is our last term, and positive 7a is now written in the middle. So we have a change in the order of the terms, which means the commutative property of addition has been used. Next, you're going to see that parentheses are now being used to group 3a plus 7a. When grouping symbols are used here, that means the associative property has been used. Be careful how you abbreviate that one. Next, we have a multiplied by the quantity of 3 plus 7. So you'll notice that a has been factored out, and then we would have to distribute. A times 3 is where 3a comes from, and a times 7 is where 7a comes from. So the distributive property has been used to rewrite these terms. Next, we have a multiplied by 10 minus 5b. So where does this 10 come from? Well, 3 plus 7 simplifies to 10. So we've just done some simplification here. Finally, 10a minus 5b. We had a multiplied by 10. Now we have 10 multiplied by a. So what's different here is the order of those terms. Change in order is commutative property. Since it's multiplication involved, it's commutative property of multiplication. Example 2. We're going to simplify 23 plus 5x plus 7y minus x minus y minus 27, and we'll justify our steps. So the first step, we just wrote down the problem. That's the original statement. Next, we have 23 minus 27 plus 5x minus x plus 7y minus y. So it looks like 23 is still the first term. And then 27 is written. So we change the order there. Then 5x, and then another term with x, term with y, another term with y. So we've rearranged most of these terms. So a change in the order. A change in order is the commutative property. Next, we see grouping symbols being used. We're taking 23 and negative 27 and grouping those because they are like terms. They're both integers. And then we're taking the terms written with the variable x and grouping those. Finally, we're taking the terms with the variable y and grouping those. So when you have grouping symbols used, the associative property comes into play. Now, what are we doing with our first group? 23 minus 27. That is the same as negative 4. 5x take away x is our next group, and 7y minus y is our third group. So we've done simplification of that first group. All right, next we still have our negative 4 as the first term, and we're going to notice that common variable x, factor that out, so it's written using the distributive property, and also the same for the terms written with the variable y. Finally, we've simplified 5 minus 4 and 7 minus 1, and notice that x times 4 is the same as 4 times x, y times 6 is the same as 6 times y. When you change the order, that is going to be the commutative property. For example 3, we simply start off by writing out the problem. We've got the original statement, and now we have 3x. So it looks like 3 was distributed. 3 times x gives us 3x. 3 times 2 would give us eventually 6. And minus 4 is just copied. So there's not any change in the order. We have simply distributed. In our next step, we can see the first and last terms are the same. What's been done in the middle is simplification. Next, 3x has not changed. But notice we've changed the order of the terms. A change in the order is commutative property. Now the reason why the order was changed is because we want to have these like terms together so that we can group them. Grouping them is the associative property. If you have those like terms grouped, then look what we can do. We can factor out x and rewrite using the distributive property. By doing this, we can simplify what is in the quantity. 3 minus 4 makes negative 1. This is another simplification. And finally, you can see that x times negative 1 has a change in order. That negative represents negative 1. So negative x plus 6 would represent the commutative property, a change in the order. For example 4, why is it true that 3 times the quantity of 4 plus x is the same as 3 times the quantity of x plus 4? So let's see what's different. We have 3 outside of the grouping symbols. 4 plus x is now written as x plus 4. So do you notice anything that's different here? It's a change in the order. So a change in the order is the commutative property. Number 5, y is 3 times the quantity 4x equal to 3x plus 4 multiplied by x. Well, if we look back to real numbers, a, b, c. A is 3, b is 4, c is worth x. And now we are changing the grouping. We had grouped 4 with x, but now we're grouping 3 with 4. A change in the grouping is the associative property of multiplication. And finally, number 6. Y is 12 minus 3x equal to 3 times the quantity of 4 minus x. This one might be a little trickier if you haven't used factoring in a while. So what was actually done here with the coefficients 12 and 3, we notice that both 12 and 3x are divisible by 3. So once you factor out 3, you can use the distributive property to fill in this quantity. 3 multiplied by 4 makes 12. 3 multiplied by negative x makes negative 3x. So the distributive property was used here.